Determine all intervals of concave up or concave down, and determine the coordinates of all inflection points, including cliffs, for the function f of x equals 4 minus 12x plus 6x squared minus x cubed. The first thing to do is find the domain. F of x equals 4 minus 12x plus 6x squared minus x cubed, which is a polynomial, and a polynomial has a domain that is all real numbers, or negative infinity to positive infinity. The next thing to do is find all candidate numbers. We will need the second derivative for this. We will start with the first derivative. F prime of x equals, the first term is a constant with no x, derivative is 0. Second term is a constant times x, the derivative is the constant. Third term is power rule, bring down the power, multiply with the 6, subtract 1 from it. Fourth term is power rule, bring down the power, multiply with the negative 1, subtract 1 from it. We can now find the second derivative. F double prime of x equals, first term is constant with no x, derivative is 0. Second term is constant times x, derivative is the constant. Third term is a power rule, bring down the power, multiply with the negative 3, subtract 1 from it. We will want to fully factor the second derivative. There is a common factor of 6. Factoring it out will leave behind a 2 minus x. We can now set the numerator equal to 0, and the denominator, if there is one, also equal to 0, and solve for all x's. Because of the factor 2 minus x, x will equal 2. We'll now check to see whether this is in the domain. The domain is all real numbers here. X equals 2 is a real number, and we keep it. It is a candidate number, a candidate to be a possible inflection point. We can now draw a domain line, a line representing the domain. It has no left end because it begins at negative infinity, and it has no right end because it ends at positive infinity. We can put all candidate numbers on here. We have x equals 2 as the only candidate number, which breaks the domain interval up into two separate intervals. We can pick a test value in each of the intervals. We have the interval from negative infinity to positive 2. We can pick 0 in there. And positive 2 to positive infinity, we can pick positive 10 in there. We can test the concavity on each of these intervals by plugging the test value into the second derivative. We don't care about the value of the derivative, just whether it is positive or negative. So the best place to plug in is the fully factored version of the second derivative. Plugging the test value of 0 in there, 2 minus 0 is a positive, times the positive 6 is still positive. We have a positive second derivative, which corresponds to concave up. We can now plug the 10 into the fully factored version of the second derivative. 2 minus 10 is a negative number, times a positive 6 is still negative. We have a negative second derivative. This corresponds to a concave down interval. So we have concave up on the interval negative infinity to positive 2. We have concave down on the interval of 2 to positive infinity. Right at the candidate number of 2, we have the concavity changing. It's going from concave up to concave down. That makes x equals 2 an inflection point. It has an x-coordinate of 2, and it has a corresponding y-coordinate that can be found by plugging the x-coordinate back into the original function. So y equals f of 2, which is 4 minus 12 times 2, plus 6 times 2 squared, minus 2 cubed, which equals 4. Minus 12 times 2 is a minus 24, plus 6 times 2 squared is a 4, and then minus and 2 cubed is an 8. 4 minus 24 is a negative 20. 6 times 4 is a positive 24, and then minus 8. A negative 20 plus 24 is a 4, and then minus 8 is a negative 4. So we have a corresponding y-coordinate of -4. So we have one concave up interval, one concave down interval, and an inflection point at 2, -4.